Hello, my fellow code toasters. Welcome to System Design with your toaster code. So today we are building something every FAANG interview loves and every backend developer secretly fears, and that is a URL shortener. Yes, like bit.ly or when your ex used to send you fake just friends links. Let's break this down like your last relationship. Short, confusing, but full of analytics. What is URL shortener? Imagine your long URL, something like, hey, buy flower from myguild.com. So this is a very long URL. If you have to use it, let's say in a tweet or in bio, they have the limitations of the word. Okay. So there you cannot put this such long URLs. So what the URL shortener will do? It will short this URL to something like this. That's it. Short, clean, and emotionally detached. Now, why do companies love this? And why they ask this question in a lot of interviews? Because it saves space in tweets, messages, bios, because you don't have to write a long URL. Okay, because they have the word limitations, and where you have word limitations you cannot put a 2 lines long URL. Now it also tracks how many times a link was clicked. Yes, just like how many times your crush saw your story, just like that. And also it keeps your branding pretty, like your startup.io/xyz. Now let's say some of the real world examples like bit.ly, Linktree, and there are plenty of it. Okay. Now let's see the functional requirement. Shortener. I mean, it's a pretty basic thing in a URL shortener. Here, you will give a long URL and in return you will receive a short URL. As simple as that. Then comes URL redirection. Now, what is URL redirection? URL redirection means your every long URL is mapped to a unique short URL. So whenever anyone will click on that short URL, it will get redirected to that original long URL. Then we have avoid duplications. That is, you have to avoid duplicate entries. Let's say I am creating a short URL for a specific YouTube video. Let's say for one of my video. Now I have already created a short URL from bit.ly. Now if you will go there and you will create the same thing, imagine how much they have to store. Okay, and it will also create redundancy because there are now more than one same long URL. So instead of that, they create the same long URL and the same short URL and they map it. So whenever you will enter a long URL to create it short, what they will do, they will first check in the database that whether this is present or not. If there is present, then they will give you the same short URL which is already present. Then we have analytics. It tracks who clicked. Okay, like from where and when. Like scary but cool. Okay, because it will keep the track of the link, that how much time the link is getting clicked or where it is being shared. Okay, you can keep a track of that. And then speed. The system should be fast, like get out of WhatsApp group fast. Now let's see non-functional requirements. High availability. Now what is high availability? So you have created a short URL for your long URL. Okay, and whenever someone clicks on that short URL, it redirects the user to that long URL. Now if that's so I have created this short link from bit.ly. Now if their server is not working, then what will happen? Okay, then it will not redirect to the original URL. Then that short URL be like invalid. So it should be like high availability, or it should be working all the time. Then we have low latency. So whenever you are redirecting your a user from that short URL to that long URL, then it should be fast. It people should not feel like, okay, it's taking a lot of long time in redirecting. Then we have scalability. There can be millions of users requesting every day, so your application should be scalable. Then we have collision resistance. That is, you should always generate a unique short URL. There should not be any collision, like I gave a bit.ly a long URL of a YouTube video. Okay, and you gave a long URL to bit.ly of, let's say, any article. Okay, and what if it gave you the same short URL? Okay, then there will be collision, because now the same short URL will redirect to which one, the video or the article. Okay, so the generated short URL should be unique and mapped to just one long URL. And it should also be able to handle high read to write ratio. Now let's see its high level architecture of this URL shortener. Like before we dive into that its architecture diagram in detail, here is how the system basically works. So there we have a user. It sends a long URL to URL shortener service. Okay, and URL shortener service generates and sends the short URL to the user. And URL shortener service stores that long URL and short URL mapping in the database. Now, when someone hits the short URL, we redirect them to the original URL because it's we have already saved that mapping in the database. And in the meantime, we silently collect the analytics in the background. And the API will look something like this. The client will send to the URL shortener service a long URL. Okay, and this is how we will store in the database the mapping. Okay, the short URL mapped to a specific long URL. Now let's dive into URL shortening flow. Okay, the moment where your giant chaotic URL turns into a cute little shortcut, like turning my toxic X into just X, clean, efficient, and far less painful. Let's understand it through the diagram that how this flow works. So the client will send a post request to the API gateway. What will be the post request? The post request will be the long URL. We just saw the API. Okay. It's like saying, yo, can you make this mess cleaner? Okay. Then API gateway will reach to URL shortener service. Okay. The gateway routes the request to our core service, the URL shortener service. And this is the brain behind the magic or chaos, depending on your coding skills. Then it will check for duplicates in the database, that whether this long URL is already present in our database or not. If there is already present, then it will return the short URL, because before you waste the energy creating a new short ID, you can check that have we already shortened this exact URL before. If yes, we return the existing short URL, because why create 10x contacts when one is enough, right? So if not found, then generate a unique short ID and return the short ID to the client. Now, how you will generate a unique short ID? Now, this is where comes the actual shortening logic. You can do this with base 62 encoding or a database auto increment ID as well. Okay, you can also use the hashing, like you can hash the long URL like SHA-256, or you can use UUIDs like but they are long and ugly, just like a 3am text from your situationship. Okay, so we prefer base 62 because it's short, alphanumeric, and easily fits in URLs. And when there is no duplicates found, we store that mapping in the database. Okay, with the long and short URL we just saw the API. And after you storing in the database, you return the short URL to the client now shows the link, tweet it, paste it into bio, or worst of all, uses it in a group chat full of engineers who will try to reverse engineer it. So that's how shortening works under the hood. So we have shortened the URL, but now what? So someone clicks on this that tiny link and they expect to teleport to the big original one instantly. No lag, no drama. So let's walk through the redirection flow, the real MVP of the system. Now, how the redirection flow works. So the client will click on any short URL and the get request flies over to our API gateway. Think of this as your friend texting, bro, where does this link go? Then our API's gateway first stop is Redis. Redis is the speed in memory cache. Okay, it asks that, hey Redis, do you know where this ABCD1232 points to? If Redis has the answer, then cache will hit and boom, instant redirection. But if not, I mean, when you will miss the cache, we fall back to database. Okay, now why Redis? Because it's fast, like replying to are you still awake at 2 a.m. So if Redis doesn't have the key, the gateway queries the primary database. The database store all mapping short and long. Okay, and once the database returns the long URL, we update Redis so future requests are faster. This is called a cache aside pattern, and no, it's not something you skip like side salad. Okay, then API gateway sends a 302 redirect to the client. Okay, now why 302? Because it says, hey browser, this is a temporary redirect, don't go caching this forever. Okay, we use 302 so that we can change the destination of short URL later if needed. If you want a permanent redirect, then use 301. But once you do, browser will never ask again. And that's a commitment from browser. A quick recap if you want, then it will be like client hits get ABC1232, then gateway checks Redis, then if miss, then fall back to database, and then update the Redis. Okay, and then gateway returns 302 and it redirects to long URL. Simple, fast, cache first, and flexible. Alright, so the user clicked the short URL, got redirected, all smooth and fast. But we are not done yet. Just like Instagram knows you zoomed into that photo, we are logging that click. This is where link analytics comes in. But why we are using link analytics? Because product managers or your managers, they are sometimes go too deep inside anything, like, oh, hey, why this is happening, how this is happening, you should know everything. Okay, so to handle these product managers, like product manager can ask like how many people clicked that link, from which country, on which device, and was it someone's cat. I mean, you never know product managers. Okay, so we have to log timestamp, IP address, user agent like device in the browser. Okay, then referrers, that if anyone is referring that link, and maybe even link ID. These things you have to log, and this is where the link analytics comes into picture. Now, how link analytics flow works? So right after the redirect is sent, the API gateway logs a click event. But here is the catch: it doesn't wait for database call. It just drops the data into a message queue like Kafka or SQS. This is a non-blocking logging, meaning we don't slow down the user's redirect. Just like stalking someone's profile, silent, fast, and slightly obsessive. Then the gateway it sends the click event to event queue, that Kafka and SQS. Okay, and the event queue reaches out to analytics processor. The analytics processor is our worker behind the scenes. Okay, it reads each event from the queue and processes them one by one or in batches. Think of it like that one guy in that group project who actually finishes the report. So once it's processed, the event is saved into analytics database. So this could be a NoSQL database like MongoDB if events are varied and high volume, or a time series database like InfluxDB, or if you want chartable data. And this is where dashboard gets their number from, the one your manager opens in meeting to say, hey, we need more clicks. Okay, so this is how this link analytics flow works. Now, why this is a smart move? Because it's async. Okay, no latency penalty, and we are using queue here, so it's scalable and fault tolerant, and the database is like permanent and queryable logs. So we have now turned just a simple redirect into a data gold mine, and just like that, we just built a full-blown URL shortener system. Okay, from shortening long URL to redirecting them, and even stalking users legally via analytics. So if you have to recap the all three flows, that URL shortening flow, redirection flow, and analytics flow, so let's see it quickly. Let's start with URL shortening service. So first, a post endpoint hits our API gateway, then gateway routes to URL shortener service. Okay, we check the database for duplicates. If not found, generate a short ID using base 62, store mapping in database, and return the short URL. Now the redirection flow. So client hits the short URL. Okay, gateway checks Redis. If cache hit, return 302. If cache miss, query database, update Redis, and redirect to long URL. Now let's see the analytics flow quickly. So gateway logs click event to message queue, and analytics processor consume events, store data in analytics database. Okay, and all done asynchronously because performance matters, and we are not clingy. Now, one of the most important part of the system design interviews are the design trade-offs. Okay, so let's see the design trade-off. So first, let's say 302 versus 301. We redirect. We have two redirections, 302 and 301. Okay, and 302 it lets us change where the short link goes later. Okay, because otherwise browser will store in the cache. Okay, then 301 it is permanent and cached aggressively by browser, so you cannot change it. Then we have cache versus database. So Redis is fast but eventually consistent. Okay, and database is slower but reliable. Now we have multiple ways to create the short URL from the long URL, and two of the major one that is used widely is hashing versus base 62. So hashing is very unpredictable and it may collide, and base 62 with auto increment ID is simpler and scalable, but requires a centralized ID generator. Consider Snowflake if distributed. Now comes the important part is how you are going to store that mapping in the database. That you can use queue plus processor versus a direct database, right? Okay, the queue is async plus scalable. Okay, and database write is like it's easy but blocks redirection flow. So when asked in an interview that can you design a URL shortener, so you have to say this answer in a specific stages. Okay, and in a specific order. Start with high level, where like we will expose two main APIs, one for shortening, one for redirection. Then talk about the storage, like I'll store short long mapping in a database and caching for performance. Then add scalability, like we'll use Redis as cache and analytics will go through an async queue. Okay. And if you want, you can mention this bonus point, that is, we can add support for custom aliases, link expiry and branded domains later, and boom, you are halfway to that offer later. So this is how you build a URL shortener, from full length commitment to short term redirection, just like your dating history. So we have hashed, redirected, stocked for analytics purpose only, and cached our way through the system. And if you made it till here, congrats, you are officially more reliable than Redis under pressure. If this video helped you, hit that like button, like you hit that F5 button during production deployment. And don't forget to subscribe to Toaster Code, where systems scale, code breaks, and joke stays just borderline HR safe. Until next time, keep your URL short, your servers up, and your X out of your system design. This is Toaster Code signing off. Thank you.